Okay, hi guys. Good evening. I hope I'm audible to you. Am I? Let me know the through the chat whether I'm audible. Yes. All right. Okay. Right. Thank you. Okay, it's not about past papers. We are having a recap session. Right. Okay. Okay. Right. So today we are going to do recap session about chemistry. We are going to do about chemistry. So when we talk about chemistry, yeah, I said I will be doing the grade 11 as well. As you know, we have session 1, session 2. So this month we are having the part 1 session. We will be only covering few parts of the lessons. As you know, I'm taking a bit of time. I'm taking a bit of time in order to complete your essay type, a structured essay, what are the lessons that would appear in your papers, and everything. We are doing outline sessions, right? So since we are discussing about the outline lessons that is important for your O levels, it might take a bit of time. So because of that, we can't complete the whole recap session. So since because of that, I said you I will be keep posting you about the session 2 dates. By December, you will be having another session by December where we will be covering some of the lesson. So recordings now, I think I have sent you the live link, right? The live stream link of YouTube. So when I have sent that to you, if you like say whenever you are free, you wanted to revise the lesson, you can just click that link. It will be same as the recording. It's already recorded in the YouTube. So I think I don't wanted to send you back again as a recording, but I do every time send it back again to remind you to watch this recap session. I might send you, but if you feel if I'm late to send, then you can click the same link, watch the session. Okay? Right. So today, what are we going to do is today we are going to learn chemistry. We are going to learn about chemistry. So, what are the important parts in chemistry, and why is chemistry is very less in amount when it comes to the questions and everything you will be learning today. So, I hope you are ready. I hope you are ready. Okay. So today we are going to discover what are the lessons in your syllabus that is belong to chemistry, that is belongs to chemistry. So when I take the chemistry, let's take the grade 10, let's take the grade 11, and we can say the most tested, the most least tested. We can say the most least tested competency is chemistry. So chemistry is very less in question than you compare with the biology, physics. I told you out of 100%, 25 percentage only you will see the questions related to chemistry. So let's take the grade 10 lesson. So what are the grade 10 lessons that you have related to the chemistry? Unit 3, it's about the structure of matter. So here you will be discovering about the atomic number, periodic table, chemical formula. You will be learning about the metals, non-metals, characteristics of periodic table, such as you will be learning about first ionization, electronegativity. Then you will discover about the oxides of the period 3. So these things you will be learning in the unit 3. So these are the things that is belong to the unit 3. Then the next lesson is unit 7. Here Avogadro's constant, atomic mass unit. mole, calculations related to the concentration. So many concentration questions related to that you will be receiving in the unit 7. Okay. Then when you come to the unit 10, it's about the it's about what? It's about the chemical bonds. So you have the ionic bond, then you have the covalent bond. So you will be learning about those, how to identify this element. This particular compound is an ionic compound or covalent compound. So you will be learning about that in unit 10. Then unit 16 is about you are introducing newly to the activity series. How are these elements are being arranged into the activity series. Then you have four types of chemical reaction: single displacement, double displacement, decomposition. Then chemical reactions, you have to go through that. Then you have about production of gases under this lesson. Then you have the unit 70. Unit 17, if you take, it's about rate of reaction. The most tested part that you get in rate of reaction is what factors affecting rate of reaction. Then come to the grade 11. So when you come to the grade 11, again the unit 3 is very important in your grade 11. I would say it's about what? Mixtures, homogeneous, heterogeneous mixtures. Then how to separate the mixtures, the physical methods like distillation, extraction of salt, then calculations related to that. So you will be learning under that, under this unit 3. Unit 7, acid, bases, salt. So you will know what is acid, what is base, what is salt. The most important part that will come under this lesson about indicators and balanced chemical equation. Then you will come to the unit 8. It's about the heat changes associated with the chemical reaction, exothermic reaction, endothermic reaction, and the diagram, the energy level diagram you have to remember under this lesson. I'm just recapping whatever the things that you have learned here. Then unit 12 is about electrochemistry. So here you study about electrolytic cell, electrochemical cell. Then you study about how these pure elements are produced by using the equipment called down cell. Then rusting, corrosion, how to prevent the rusting. All these things you will be learning under unit 12. Then unit 14, hydrocarbons and their derivatives. So when you take the hydrocarbons, under these you will be studying about the alkane, alkene, alkyne. So you will study about the derivatives, polythene. So the structures of them, everything will be coming under this. So your question is, which is the most important lesson that will be covered? Okay, so which is the electronic lesson comes under the physics. Okay, right. So you might ask me, which is the most important lesson that will appear in your exam paper? So for now, listen to me. Not like the biology, not like the physics. There is no what do you say, we can't say this lesson you have to omit. I won't say you something like that, but I will say you that if you are focusing on unit 3, always remember the question unit 3 can be combined with the grade 10, grade 11, unit 3 can be combined together. At the same time, this unit 7 also can combine with the unit 3 of your grade 11. They can be appearing like that. So they don't only specifically ask question related to the unit 3 in grade 11 regarding the mixture. They can combine with this one. They can combine with this lesson. So that means if I am talking about the Avogadro's constant, mole, concentration, so you will be discovering about that, and I will say you that from the lesson 7 you won't get any big question, especially you get only MCQ. So that means you have to know how to find the Avogadro's constant of each elements. Then come to the unit 10 of your grade 10. Unit 10 is very important, especially you have the Lewis structure. You know the Lewis structure, right? So every year there will be a Lewis structure that you have to draw, which comes under the covalent bond. I will teach you to draw the Lewis structure if you are a person who by hearts the Lewis structure, okay? I will teach you how to do this one, but before that, I'll tell you this unit 10 also very very important lesson. Unit 16 also very important. Unit 17 is not that important because I will say many times it's about the chemical reaction, right? So this chemical reaction can be combined with the unit 8 of your grade 11 because this is also about the chemical reaction. This is also about the chemical reaction. The only difference between these two is what? The production of heat. So here you have the absorption of heat, production of heat, exothermic reaction, endothermic reaction. So these two lessons can combine together to create one question. Okay. Then unit 12 is very important, especially you have a lot. That means the one of the biggest lesson I would say in your chemistry is unit 12. Then next is mixture. Then after that only you will go with the no 16 unit in mixture. Then after that changes in matter. Then finally you will have this unit 3 of your grade 10. So that means if you're very good in lesson unit 3, you can handle them in your left hand. So you can handle everything in your left hand because you know what? The most important part in your chemistry is your foundation. So if you know the foundation, the rest of them you can handle it. So that means you have to be very good in the lesson 3, 16, 3, again 12. The mostly questioned lesson in every year O level paper is what? 3, 16, 3, 12. Okay. Then if I say others, they are also important, not as important as these people. Got it? Understood? So, yeah, give me around 5 minutes. It's Azan here. Once the Azan is over, we'll continue, okay? Thanks for waiting. Yeah, so physics is hard. It's not hard, it's the way you understand it's hard, okay? The way you understand is the problem, okay? So if you understand the concept, it's like same like maths. You don't want to stick into one theory. You don't have any theories to by heart in physics. It's very easy because you have to understand what is behind the logics, what is behind this part. So if you know to do, if you know the equations, if you know what is the theory behind that, then you don't want to by heart. Every year you get the physics question, which is always different, which will be always different. That means I can't say exactly this question might be appearing in your paper because every year they generate a new question for the physics. But chemistry is same, like they are stick on to that. But when it comes to biology, also say, but physics is not like that. They create questions every year. So that means you have to be very good in what? Equations, the logic behind that, and everything. Okay. Don't worry, Hannah. I'm here for you to help you with the Unit 16, Grade 10. Don't worry. The Unit 16. You mean the changes in matter. Okay. Right. So now what is happening is, I was saying, these are the most important lesson and less important lesson. So that means you should understand which lesson is the head of the lesson. So which means the chemistry head is Unit 3, Unit 16, Unit 10, Unit 3, Unit 12. So out of total 10 lessons of chemistry, 5 lessons are very, very, very important. The rest of them are not that important. You can just study by yourself. But the others, I need to guide you to get it good. Okay, right. Okay, so listen. Now, when it comes to the chemistry, okay, when it comes to chemistry, let me tell you what appeared in 2024 paper. So 2024 paper in the part A, structured essay. So when you take the part A structured essay, what happened is you need to understand clearly in the question number 3. Remember, mostly in the question number 3, you will have the chemistry question. So they will give you the chemistry question in the question number 3. Remember, it's always the same pattern. Every year, take the structured essay, look at the question number 3. That question number 3 will have the chemistry. So, you know, for the structured essay, how many marks they are giving? 15 marks. So, if you take the question number 3, they can divide it as part A, part B. In the part A, they had given the lesson grade 10 Unit 3. It's about like they had given an empty periodic table and they asked to name the periodic table with the symbols, and they had asked some questions related to the symbol. So that's how you do every year in your term papers, right? So every year you get a periodic table. You have to, by looking at the periodic table, you have to answer the question the same way that was appeared last year, 2024 batch. Okay, right. So then again, they combine this Unit 3 lesson with the Unit 10 of your grade 10. Especially, they have spoke like they have said if the element from sodium, if the element is from chlorine, so sodium, chlorine combined together. So they have asked you to find the bondings, whether it's an ionic bond or a covalent bond, and then they have asked you to identify the isotopes. So they have given you 3 isotopes and you are supposed to find the values of the isotopes. So they had given like that. In the part B, they had given the grade 10 unit 16 question. So that is about what? Extraction of what? It's not extraction of iron. It's about I remember it's not unit 16, it's grade 10. It's unit, not grade 10, it's grade 11 unit 12. They have given a question related to rusting. So you have to answer the question related to rusting. So that was appeared. So look here. So in the question number 3, you see 3 lessons. 3 lessons are combining together in order to form as a one structured question. Right. Come to the question number 6. Question number 6, part B, where you get 20 marks. Where you get 20 marks. So which means, so in the part B, question number 6, under that you also will be divided as part A, part B. So here they have given grade 10 unit 16. They had given grade 10 unit 16 about extraction of iron. They have given about extraction of iron, and then they connected this lesson. Okay, they connected this lesson with the Unit 7, Unit 7, Grade 11. Unit 7, Grade 11. So here they were speaking about acid, bases, indicators to identify. So Unit 7, Unit 16 were combined. Then come to the part B question. So when it comes to the part B question, again grade 11, Unit 12. Now see how important is Unit 12. How many times you see a question related to Unit 12? Two. So if you take the Unit 12, they had given a diagram. In that you have to answer the down cells experiment, how to extract the sodium and chlorine from the seawater. So they had asked a question related to that. Okay. So then when it comes to again unit, that means question number 9 under the essay type question, in the part A, they have used the unit 3 of your grade 11. Unit 3 of your grade 11 has been combined with the Unit 7 plus Unit 8. So Unit 3, Unit 7, Unit 8, all of them combined together, they have formed as one question. So especially they have asked question related to the chromatography, solvent extraction. Then they have asked you to give the reaction, whether acido, bases, or neutralization. And then in the question number 8, connecting here, they have asked to draw the diagram, whether it's an exothermic reaction or an endothermic reaction. So you have to draw. So when you see here, you can see the most questions are from grade 10, grade 11, especially Unit 3, Unit 12, Unit 16. So these lessons are very, very important. So if you are targeting to score an A in science, you also have to focus on chemistry well. And also say now, imagine if you're not a person who is not good in chemistry, if you're not, let's say, if you're not a person who is not good in physics. Let's say you're not choosing the question number 9, because in the question number 9, along with that part B, you will have the physics question. You are the person only selecting these two questions. So what is your marks that you can expect? 35. So you can expect 35 out of 200. So 35 out of 200, you can expect this marks. So if you are going to take this as out of 100, 27.5 marks you can get. So that means imagine if you are getting 27.5 marks in the in the chemistry, and if you're taking 25 marks out of 100 in biology, say if you're only focusing in biology and chemistry, that means you can get a B. You can get a B. You can get a B if you're only focusing on chemistry and biology only without touching the physics. That means you can score a B, but your answers has to be correct. Did you understand? If your answers, and if you're getting the full marks in biology, if you're getting the full marks in chemistry, as well as if you are if you're scoring well in the MCQ, you can get what? You can get a B. So that is one way, that if you're a person who is targeting, has no idea which grade will I fall, then definitely I would say you might fall under B. And also if you're only focusing on biology and only physics, then also you might be falling under B. So if you're focusing on all three competencies, you will be focusing what? You will be focusing to reach an A, right? So that is the overall idea how your last year paper was appeared. So this year paper, your February paper, I'm gonna give you the lessons that we target. Under those lessons, I will write you the subheadings. Make sure to collect those subheadings, because under those subheadings, till now the question has not appeared. Sometimes it has been appeared 2 years ago, 3 years ago, but there is high chance they can take it again back again to your that means for the current 2025 batch, they can take it. So since because of that, let me write it some of you, and you are going to take it the note down, right? Okay. So this year paper, this year 2025, as I'm assuming, okay, as I'm assuming, this year in your part A, in your part A, question number 3, you can get these lessons. I'll write it down with another color marker. So remember, I'm writing Unit 3. From your Unit 3, grade 10, you will get questions related to uses of metals, and non-metals. Then they can give you identify elements. Identifying elements using electronegativity, or first ionization graph. Most of the time, first ionization graph, okay? Electronegativity question can be asked. First ionization graph. You should be able to know how to draw that, okay? Then I can say this unit 3 can be combined with the unit 16, grade 10, especially about under this preparation of gases. Preparation of gases, I think you know how we prepare the oxygen gas, carbon dioxide, and hydrogen gas. Preparation, collection, and identification of gases, right? Yeah, I will teach whatever the things I told you, I will be teaching. So you don't want to worry about it. So preparation, collection, identification of gases. Also, like every year, we can also expect extraction of iron. I make sure that you have to know the extraction of iron very well. Then that's easy. You're not going to focus a lot on that. Then you can get Unit 14, Grade 11, hydrocarbons and their derivatives. That means like the hydrocarbons, types of artificial polymers. You can get artificial polymers and structures. So you have to know that, to draw the structure, to draw them, identifying them. So you should know the artificial polymers and structures. You have to know natural polymer, artificial polymer, those things you have to know. So if you have done writing, I can write the next question. I mean, the question number 6. What are the lessons that we... If you're okay, I can go with the next one. Shall I raise? Great. Okay. So question number 6. Question number 6. If I take the part A, we can take unit 12, grade 11, okay? So we can take unit 12, grade 11. It's about electrochemical cells, those diagrams, electrochemical and electrolytic, lytic cell, and diagram. They will give you a diagram and ask you to identify which one is electrochemical cell, electrolytic cell, write the half oxidation reaction, half reduction reaction, overall reaction, observation. You should know that, okay? Okay, next one is under the part A. Unit 3, grade 11 can come. So especially we can write determining the concentration of the solution. That means you have to remember. Can you remember you studied the steps to do make a perfect solution, standard solution? To make a perfect, to make a standard solution, you did some calculations to find the mass and those steps. So those things only will be appearing here. So determining the concentration of a solution and calculation. Calculation that will come. So that I can expect in the part A. Part B, we can expect, okay? No need to memorize, it's easy. Yeah, I will be teaching. So don't worry, as I told you, I will be teaching you everything. So, Unit 7, grade 11, you will get acid and bases. What do you say? Balanced equation. So whenever you are writing anything related to the chemistry, make sure the equation is balanced unless you are getting wrong. Okay. Then again, unit 12, you can get about how to prevent rusting. How to prevent rusting, they can ask you it's a cathodic reaction, or they can ask you to write some things related to that. Also, they can even ask you to like to write the half reaction, whole reactions and everything. Something related to the rusting might appear, because it's like always they say the unit 12 of your grade 11 is very important. They can take any questions out of that. Maybe one thing that has been appeared last year also can be appeared. So it doesn't mean that last year it has come, this year it won't be coming. No, not like that. So it's like a small guess, and this is how it has been working all the years, right? Okay, I'll erase it. We'll go to the 9. Question number 9, part A. What can come? Okay, so question number 9. Yeah, question number 9. Yeah, question number 9, we can say the part A. Mostly in the part A only you will see the chemistry portion. So you can get unit 16, grade 10, activity series. I mean, you can get questions related to the activity series. They can ask you what method is used to extract, or what method is used to produce the sodium, chlorine. They can ask you questions related to the activity series, and they can come with the mole calculation. Mole calculation comes under this lesson only, because they can give you a balanced equation. They can ask you to find the number of moles. So I know some of you all doesn't know about it, but I'll teach you that, okay? Then unit 8, you can get the unit 8, grade 11, exothermic reaction. Very small part only you will get. Exothermic reaction, endothermic reaction is very easy. Endothermic reaction. So you have to know what? You have to give example under that. They can ask you to give example, demonstrate that. Demonstrate products, and they can ask you to write about the neutralization also. Neutralization part also can be combined. Then unit 10, grade 10, you can get illustrating. You have to illustrate the ionic compound. You have to draw the ionic compound and show as the diagram ionic compound. And also they can give you about polarization, and intermolecular forces of water. Intermolecular forces of water they can give you. So these are the things that will be tested. I hope that will be useful for you. Yeah, I hope it will be useful, and that also will be making you to motivate, focus on the part of the lesson. Instead, you are just giving up. Okay, right. So yeah, I would say chemistry is one of my favorite thing to do, because chemistry is easy until you understand. Once you understand the fact, you will do it better. You will do better. Okay, so that is what I could say. Shall we get started? So I am going to start with the lesson 3. I know I have to fix your foundation. So I have to fix your foundation. So since we are going to start from the unit 3, I'm not going to make it boring, but I'm going to make it interesting, because you are also also gonna learn with me. So how are we going to do? Everything will be focused on the board. So first focus, and then if you have any doubt, you can ask me. As I told you, if I am teaching, I will be only focused on the board. I will not see your chat. So whenever there is a doubt, like whenever I have done with a part, I will ask you whether you understood or not. At that time, you can clear your doubts. Okay. Right. Okay. So let's get started. So unit 3. So, under the lesson Unit 3, I have to teach you the important parts under the Unit 3. Especially, I will be teaching you about the electronegativity, first ionization, then oxides of what? Oxides of period 3, how to identify them, and chemical formula, polyatomic ions, isotopes, then mass number, atomic number, valency. So these things you will be learning in detail with me. Okay, so first, we are studying about matter, right? We are studying about matter. So we know in chemistry, the matter is made up of atom, which means whatever the things on the earth which is made by a particle, that particular substance is what? It is made up of atom. So we know it is made up of atom. So when we say atom, inside the atom you have small atom. We call it as what? Subatomic particles. We call it as what? We call it as subatomic particles. So the subatomic particles are three subatomic particles we have. One, we have the proton. One, we have the proton. Other one, we have the electron. We have the electron, and then we have the neutron. So the scientist to introduce the atom is John Dalton. So John Dalton is the scientist. Sometimes it can appear in the MCQ. I have seen many times the scientist names like bionomenclature. These things can be appear the scientific names, italicized names, which is belong to the unit. I think so. Unit 13 of your grade 10 biology lesson. So these things, everything will be appearing where in your MCQ. Some short things that you don't want to take it seriously. Those things will be appeared in your MCQ. So listen to me carefully. So you have the subatomic particles. So what is happening is these subatomic particles should be arranged, right? It should be arranged in the atom. Like you say, you are taking a classroom and you are arranging the classroom by putting the chairs, chairs, whiteboard, blackboard, everything. You are arranging it right. Same like that. Some scientists they did so many experiments, they did so many researchers. How this proton, electron, neutron, everything is inside the atom. So I'll tell you only about two people that is mostly that appear in your MCQ. So the arrangement that is introduced is what we call it as the planetary model, which you studied in your grade 9. So grade 9 you studied about planetary model. So this was introduced by the Ernest Rutherford. So Ernest Rutherford is a scientist who said that the proton and neutron is there, right? The proton and neutron. He said that the proton and the neutron is found inside the nucleus. That is true. Yes. So he said that proton and neutron is found inside the nucleus. Surrounding the proton, that means surrounding the nucleus, electron is revolving. So this is what you learned in your grade 9. Then when it comes to grade 10, they said that this planetary model has been upgraded as a modern atomic model. As a what? Modern atomic model. So modern atomic model has been introduced by the scientist that is Niels Bohr. That is Niels Bohr. So Niels Bohr is the scientist who introduced about the modern atomic model, which we are learning right now in our syllabus. So what did the Niels Bohr said? He just took the idea of the Ernest Rutherford and he modified it. He modified. So how did he modify? He said in the nucleus, yes, you will have the proton as well as you will have the neutron. Remember, proton is positive charge, neutron is zero charge. When plus and zero combines together, still the charge is going to be what? Plus. Okay. So this was said by the nucleus. Sorry, Niels Bohr. So now what happened? So surrounding the nucleus, Niels Bohr said that not only one like means not only one energy orbital that will not be revolving around the nucleus. He said that more than that means he said different energy orbitals will be revolving around the nucleus, which means electrons has different energy shells. So in the different energy shells there will be different numbers of electrons. So especially who Niels Bohr, he introduced the four shells, which we call it as K, L, M, N. So K orbital, he said you can have only two. In the L orbital, he said you can only have 8. In the M orbital, you can have only 16. And the N orbital, you can have only 32. So K, L, M, N are the four electron. That means electron shells. We can say it as energy orbitals. So the four energy orbitals are introduced by who? By the Niels Bohr. So he said that according to the number of electrons, the electrons will be placed according to their shells. Are you clear with that? Are you clear with that? Are you clear with that? Got the idea? Any doubts? Okay, so now what happened? All these elements. Now you know what is the element, right? So element is made up of what? It can be made up of a pure molecule or it can be made up of combination of two or more atoms. We call it as element. So if I take element, all these elements are arranged in a periodic table. They all are arranged in a table. We call that as what? Periodic table. The father of the periodic table is Dmitry Mendeleev. So Dmitry Mendeleev is the scientist to introduce about the periodic table. Now if you take the periodic table, you will have how many columns? The columns you say it as what? The columns you say it as groups. So that means can you say the groups as 1, 2, 3? No, we always use the Roman numbers to introduce what? To introduce the groups. Then the rows. If you take the rows, how many rows do you have? You have the four rows. Four rows, we call it as what? Periods. We call it as what? Periods. So these periods you introduce by the numeric way. So like 1, 2, 3. So especially, let's say hydrogen. Now you should know the periodic table. Now if I ask you to say, can you tell me the atomic number of silicon? You should be able to say me because now, almost 2 years, you are dealing with the periodic table. So, since you are dealing with the periodic table, you should know all the random elements under that with their atomic numbers. So, that means you are an expert. Okay, you are expert in chemistry. So, what is happening? So, you have to know the periodic table: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So then what do you get? You get the sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So you have only what? You have only 20 elements to be by hearted. You don't want to by heart. It's just like when you keep on dealing with the periodic table, automatically you will be remembering. The first thing when you get your O level paper on the desk, the first thing that you have to do when it comes to the science paper, first draw the periodic table. The first thing that you forget when you come to the hall is the periodic table activity series. So make sure you remember the periodic table clearly. So if you take the periodic table, listen to me carefully, you have to name the columns by the Roman numbers. So these are the Roman numbers, you know very well. So you know very well. You write it like this. So these are the Roman numbers that you have to write. Then the rows, you name it by 1, 2, 3, 4. So this is going to be what? The periodic table. So when you take the periodic table, all these elements are arranged according to what? According to their characteristics, according to their number of proton. So remember the number of proton in a atom, the number of proton in an atom or an element, we call that as atomic number. So what do you mean by atomic number? We are deciding the atomic number by the number of proton, which means it's a fixed value. If I take hydrogen, hydrogen will have the proton number 1, which means the atomic number is also 1. So remember, atomic number can be equal to the number of proton. Atomic number can be equal to the number of proton. So can you change the proton number anytime? You can't change the proton number anytime. But there is a person whom you can change it according to the situation. That is going to be electron number. Remember, electron number also will be equal to the atomic number. But by situation, whenever the element is not stable at that time, the electron can be removed, it can be accepted. So at that time, the electron number can be changed. So other than that, the proton number will never ever change. So you know that when it comes to atomic number. So what is the equation for atomic number? Atomic number is equals to what? Number of proton. Also, it can be equal to the number of electron. But what is the change you have to remember? Number of proton, you can't change it. You can't change. But number of electron can be changed according to the situation. When you remove, when you accept, number of electron can be changed. But the number of proton will never change. Did you understand? Because the symbol for the atomic number is the main person is what? Number of proton. Right. So when it comes to the number of proton, you already got an idea. Number of atomic number, you got an idea. So now you know the equation for that. Now the next thing is you have to know about the mass number. You have to know about the mass number. Remember, whenever they give a question something like this, so this is the standard way that you represent the element. Always remember the mass number will be added on the left. So, yeah, it should be added in the left hand side. On the top, you will be adding the mass number. At the bottom, you will be adding the atomic number. So they will give you something like this. They can ask you to find the number of proton, number of electron, number of neutron. How can you find it? Number of proton, we can find it. You know, number of atomic number. Atomic number is equals to the number of proton. So which means the proton is 11. If you take the electron, electron also will be equal to the number of protons. So we can write it as 11. But what is the value of neutron? To find the value of neutron, just subtract the below number with the top number, the above number. 23 minus 11, you get the value what? 12. Either you can use the equation, what? You can use the equation mass number is equals to proton plus neutron. So that means still here in this equation, you are subtracting the mass number with the proton number. Once you subtract the mass number with the proton number, you will get the value for the neutron number. So this is the way you are finding what? The proton number, neutron number and electron number. So this is the way. This is the standard way that you find it, right? So now I have to teach you something called electronic configuration. Some people still they don't know how to write electronic configuration. So let me teach you about the electronic configuration. Can you remember just a while ago I explained you about what? I explained you. So you have you have four energy orbitals. You have k orbital, l orbital, m orbital, and n orbital. So according to the Niels Bohr, he said if you take the k orbital, you should have only 2 electrons. If you take the l orbital, you should have the 8 electrons. If you take the m orbital, you should take 16. here 32. So since we are only having 20 elements, we are not considering these people as 16 and 32. We are going to take it as here also 8, here also 8. So if you don't know how to write the electronic configuration, just follow the with method that I say. So in the electronic configuration means you are going to, what are you going to do? You are going to arrange the number of electrons electronic according to the number of electrons. Okay, so you are going to, what do you say, you are going to arrange the electrons according to the energy orbitals with their valence shell. Okay, so now what are you going to do? Let's say you take sodium. If you take the sodium first, listen to me. Sodium, what is the atomic number? That is 11. So when you take the atomic number 11, by using the atomic number 11, you can find two things. What are the two things you can find? You can find the proton number as well as you can find the electron number also. By using the atomic number, you can find the proton number, you can find the electron number also. So when you take the electron number, the word electronic configuration is only speaking about the electron. It is says about what? It is saying how electrons are being arranged in the shell. So that means you are going to only talk about the electrons. So think there are there are four buses in the stand. So in the each bus, they have the seat numbers. Let's say in the bus K, they have only 2 seat. In the bus L, they have only 8 seat. M, 8 seat. N, 8 seat. So each buses has the number of seats. So these are the values of the seat. Now say the electrons are going to be the, what do you say? They are going to be the passengers. The electrons are going to be the passengers. So now think, if the passengers, 11 people are there. So first 11 people. Now if you take the 11 people, out of 11 people, how many people can get into the bus K? How many people can get into the bus K? Like 12, sorry, 2 people. Only 2 people can get into the bus K. So if 2 people has been got into the bus K, how many balance? 9 balance. Can all the 9 people get into the bus L? Can all 9 people get into the bus L? Can't. So that means out of 9, only 8 will enter. Then how many balance again? 1 balance. So that balance will be into the bus M. So 2, 8, 1 is going to be the electronic configuration of the sodium. Did you understand? I mean, the people who has no idea about the electronic configuration, I'm just giving you a small hint. Clear? Got the idea? Yes. So when you talk about the electronic configuration, simply you can understand 2, 8, 1. Just think the number of electrons as the passenger. Just think you have the shells. Just think the energy shells as the bus. So if you can combine with that, you can find it. Now let's come to the valency. So first I will show you how to find the valency. Okay. I will tell you how to find the valency, and then we will be giving you the valency table. Okay, so listen to me carefully. So um when you come to the valencies, by using the electronic configuration only, you find the valencies. So listen to me. When you talk about valencies, so valencies you are finding using what? Using the electronic configuration. So when you take the electronic configuration, now say for example, I'm taking the same sodium as the example. Now you know that the atomic number of sodium is 11 and electronic configuration of sodium is 2, 8, 1. So this bus is full. This bus is full. But is this bus is full? Is this bus is full? No. So that means in the bus there are 8 seats. Out of 8 seats, 1 seat has been filled. But the rest of the 7 seats are empty. Now think as a bus driver. Now if you are a bus driver, if you have only one passenger, will you take him onto the trip? When you take will you take him onto the trip? You won't be taking him to the trip. So the reason is because if you take only one passenger by traveling, you will be lost. So since you are lost, what you will say, you will try to get rid of this, what you will try to get rid of this passenger. So you will say convince and everything, you will try to get rid of this passenger. So that means when it comes to electron, I said electron can be removed. It can be removed as well as it can be accepted. Now think, if the electron is a negative charge, right? If it is a negative charge, if it is removed, what will be the opposite charge? Now think, if you are a person, if you are removing negativity, what will happen? You will become a positive person. Now think, if you are accepting electron, you are accepting negativity, you will become what? Negative. So think here. So when you are removing one electron, what will be the electronic configuration of sodium? 2, 8. Then what will be the charge on the sodium? It will be +1. So remember, if they are forming a charge after removing or after accepting, that we call it as what? Valency. So remember, valency will help you to combine what? Valency will help you to create chemical formula. So if you know the valencies only, you can create the chemical formula. So let me teach you about the chemical formula and the rules and how that is going to work. So you will be understanding in detail. So let me show you how this is working. So you know that the group 8 elements are there, right? They do not accept electron as well as they won't be removing electron. The reason is they are already stable and they are considered as what? The noble gas. So say for example, now in your exam they are saying, now this element, one element is combining with another element. So if the elements are going to combine with another element, you should know the valency. So since because of that, the easiest way is, if you take the periodic table, you can write it down. Group 1 element will have the valency 1, they will have the valency 2, they will have the valency 3, they will have the valency 4. Then you have to go reverse. So if you take the +4, then -4, +4 or -4, then -3, -2, -1 and 0, because they are noble gas. So if you take to the this part, when you come to the bottom of the group 5, again you have to continue. +5, +6, +7. So these are the valencies of all the elements in the periodic table. In your exam, they will not ask you to what? They will not ask you to find. That means they will not ask you to write the way of finding the valency. They will never ask you, but just have an idea. This is how the valencies will be there in your periodic table. So just get an idea. So +1, +2, +3, +4 of +4 or -4. Then go with the reverse, -3, -2, -1. The bottom part will be +5, +6 and +7, right? So these are the valencies. So now listen to me carefully. You are going to combine two elements. You are going to combine two elements. Let's say, for example, you are going to combine the sodium with the chlorine. So whenever you are combining a sodium with the chlorine or any other elements, remember the first element that you are going to write it on the first is going to be always positive valency one. He or like that means that particular element should have the positive valency. Then if you take the other side element, that has to be the negative valency. It should have the negative valency. So what is the valency of sodium? The valency of sodium is +1. What is the valency of chlorine? That's going to be -1. So the rule to create the chemical formula is, you have to forget about the signs. You have to forget about the signs. So why did I mark the signs? The reason to make sure that the first element that you are writing should be the positive valency. The next one has to be the negative valency. So you forget about the signs. You have to check whether you can simplify this anymore. If you don't have anything to be simplified, you can just exchange it to the other side. You will get the answer as what? Sodium chloride. Should I mark this as 1 and 1? No need. If the answer comes with the final valency as 1, 1, 1 on the other side, then remember you don't want it to write it as 1. You can just leave it. But other than 1, if you get the value 2 to the 9, then definitely you have to write it down in the chemical formula. So this is going to be the rule that you have to apply when it comes to what? When it comes to chemical formula. So now what you have to remember, let's say for example, if the chlorine is going to react with what? Calcium. So who is having the positive valency? Calcium is having the positive valency. If I take the calcium, it's going to be +2. Then chlorine is going to be -1. Forget about the signs. When you exchange the valency, what will happen? You will get the answer as calcium chloride. You will get it as what? Calcium chloride. So here you don't want it to simplify as you don't have anything to be simplified. Right. The next one is, let's say, for example, magnesium is going to react with what? Magnesium is going to react with oxygen. So if the magnesium is going to react with oxygen, so what is the valency of magnesium? +2. Oxygen -2. 2 and 2. Can you substitute? Can you simplify? Yes, you can simplify. So if you simplify, it's going to be 1. If you exchange the 1, the answer is going to be what? MgO. So that is going to be your answer. So remember, chemical formula is easy. So in your exam, if they have given a periodic table with not a standard symbol, they will not give any standard symbol. They will give you as A, B, C, P, Q, R. They will give you some other ways to represent that element. So if they ask you to form a chemical formula using those what do you say, elements, then remember you should not write the exact symbol. You should not write the exact symbol. You have to write the alphabets that they have provided. So the symbol that they have provided, you have to use that and you have to answer the questions. So make sure, some people they do a mistake. So they will in the question they don't read the question properly. So when they don't read the question properly, there's a high chance they can lose the marks. Even though your answer is correct, you didn't follow the rules that is already mentioned in your question. So they will say you have to use the symbol that they have provided, not the symbol that is standard one. Clear? Got the idea? Right. So now, whenever they say, now sometimes they don't give you like combine magnesium with oxygen, they can even say form the chemical formula, give the chemical formula for the potassium nitride. So when they say the word nitride, that means potassium with what? Nitrogen. When they say fluoride, then remember fluorine. If they say oxide, remember that's oxygen. If they say hide, if they say the word hide or sulfide, when they say sulfide, so sulfide means what? Sulfur. So they have used what? Sulfur. So remember the words. The words are very, 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 very important. Right. Now, when it comes to the chemical formula, along with the chemical formula, you should remember the polyatomic ions. You have to remember what? You have to remember the polyatomic ions. So this polyatomic ions, the very special one is 6 polyatomic ions that you have to remember if you wanted to score well in your chemistry. So when you take the polyatomic ion, what does the word poly stands for? Several. Atoms stands for what? Now polyatom make ions. So atom means atom. So several atoms with ions, we call it as what? Polyatomic ion. So what are the 6 polyatomic ion that you have to remember? Number 1, you have to remember ammonium. So ammonium, always remember the valency will be represented by the charges. +2, +3, plus, minus. So that means always remember on the right hand side top, you can find the valencies of whom? Polyatomic ions. Then the second one is what? Hydroxide. So OH minus. Then you will have what? The nitride. NO2 minus. So you will have what? Not NO2, NO3 minus. Then if you take the fourth one, carbonate. So if you take the carbonate, CO3 2 minus. Then if you take the sulfate, SO4 2 minus, PO4 3 minus. So these are the 6 polyatomic ion that you have to remember. Other than these, in your book, they have given you about dichromate, permanganate, chromate, bisulfate, bicarbonate. These things are not that important. You don't need to remember, but these 6 is very, 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 very important. So remember, these 6 are very, very important. If you don't know, you will be having a problem scoring well in your chemistry. So make sure you have to remember the 6 polyatomic ion, right? Clear with that? Okay. So there is a small clarification that you have to remember. That there's a small thing that you have to remember. Let's say, for example, they have given the word carbide. They have given the word carbonate. Let's say carbonate. They have given two words like this. And if I ask you to give the chemical formula of carbide, how would you give it? Like if I say carbide means you should have only carbon there. Carbon, that means carbide means they will only have the carbon. What are the elements there in the carbonate? Carbonate will have the carbon as well as oxygen. If I say sulfide means, remember, the only element that will be there is S. If I say nitride means the only element that will be nitrogen. Then if I say sulfate, sulfur plus oxygen. If I say nitrate, nitrogen plus oxygen. So remember, the words are very, very, very important. So words are very important. Polyatomic ion is very important. Then periodic table, atomic number, electronic configuration, these all will be interconnected. So since because of that, I am teaching you part by part. Yes. Are you clear with that? Right. So let me say you something. Some people, they do mistakes in chemical formula also, especially when it comes to an element with a compound. When an element and a compound combine together, at that time they will also have some problems, especially when a polyatomic ion is going to combine with the element. Then you will have some problem. Let's say, for example, they have given you in exam something like this. They have given you, write the chemical formula of sodium carbonate. So if you take the sodium carbonate, so tell me sodium, what is the valency? Sodium valency is +1. Carbonate, CO what? CO3 2 minus. So that means the valency is -2. So plus and minus, forget the signs. When you exchange it, how will you write the chemical formula? You have to write like this. You have to write in this way. So this is simple. This is simple and this is easy. But sometimes some people have a problem when it comes to the bracket. They don't know how to add the bracket, when to add the bracket. So I will tell you when the bracket will be appearing. Okay, so listen to me carefully. Let's say if the magnesium is going to combine with the nitrate, if it is going to combine with the nitrate, at that time, let's say, for example, here you have the +2, here you have the -1. So if you get a value, if you get a valency to, like, if you have a value here and if you are exchanging it to the other side towards the polyatomic ion, then remember, you have to put the bracket by mentioning. Why are we putting this bracket? This bracket says that this 2 valency 2 is belong to both the nitrogen as well as to the oxygen. So why are you adding this 2? The reason to put the bracket. To put the bracket, now say if I don't put the bracket, what will happen? This 2 will be only belong to the oxygen, not to the nitrogen. To make sure that this valency, the value is belongs to both the nitrogen and oxygen, because of that only I am adding the 2. Clear with that? So sometimes there are people who might be finding difficult in writing with the bracket because they don't know exactly how important is the bracket, right? Look here. The next one is you are going to study about the oxides of the period 3. So what do you mean by oxides of the period 3 means? Listen to me carefully. When you take the oxides of period 3, now say for example, if now oxides means what? Oxygen. So remember, if you take the metals, now the left hand side, if you take the left hand side, the elements in the left hand side, and if you take the elements in the right hand side, the left hand elements we call it as what? Metals. The right hand side elements we call it as non-metals. So how these metals and non-metals are getting divided? From the word babe. So if you take the word babe and if you put a staircase on the staircase, that means the people inside the staircase are the metals. The people outside the staircase, they are what? Non-metal. So when you take the metals, whenever the metals combine with the oxygen or whenever they are combining with the water, they will be always forming what? They will be always forming the bases. They will be turning into what? They will be turning into bases, or we call it as basic. Whenever non-metals combines with the oxygen or a water, they will be always becoming what? They will be always turned into what? Acids. So think. Now oxides of period 3 means the oxygen is going to react with sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, but not with the argon, because argon is a what? Stable. It's a stable element. So now what is going to happen? You should know the order of the oxides. You should know the order. Now think, the order that we are going to start is, if you take the sodium, think sodium is a strong base. It's a strong base. So after the strong base, you have the weak base. Magnesium with the oxygen. Magnesium oxide is a weak base. Then remember, aluminium is what? It is an amphoteric. Amphoteric means this a particular substance. That means when aluminium and oxygen combine together, they are half bases as well as they are half acids. They can react both. So aluminium can be both the acid and bases together in a little amount. So that is what we call it as amphoteric. Now come out of the staircase. So when you come out of the staircase, you have silicon, phosphorus, sulfur, chlorine. You have these, right? So you have these. So now what is happening? Silicon, phosphorus, sulfur, chlorine. You have to know they will become acids. So go with the reverse. We can say very weak acid. Silicon. Then cut this very weak acid. Then what is that? Next, strong acid. Very strong acid is going to be the chlorine. So this is how you remember. You don't want to buy hard. Just understand the pattern. It starts from the strong base, weak base, amphoteric, very weak acid, strong acid, very strong acid. So starting also strong, ending is also strong. So when you know that, simply you can understand the difference. Clear? Got the idea? So you should know the order of the oxides. So if you know the order, most of the time they give these questions. Most of the time the questions related to the oxides, you get 1 mark question, MCQ, sometimes as a fill in the blanks you might get it. So that is the way they usually give it. It's not a big thing also, but you should know it. Okay, right. So now the next thing that you have to learn is about, you are going to learn about the first ionization. So you are going to study about the first ionization. So let me teach you about first ionization in detail, because that is the place where most of them feel difficult, especially when it comes to graph or when it comes to the points and everything. You might be feeling difficult. So let me explain you first ionization in detail. So listen to me carefully, okay? So when I say the word first ionization, so when I say the word first ionization, so you have two types of ion. One, you have the positive ion, you have the negative ion. Positive ion, we call it as what? Cation. We call it as cation. Negative ion, we call it as what? We call it as anion. We call it as anion. Now, atoms with a charge, you call it as ion. If you have an atom, if you have a charge for that atom, we call that as what? Ion. So now you have sodium. You have sodium. Okay. So when you take the sodium, we remember that sodium, the metals always likes to remove electrons. The metals always likes to remove electrons, which means always the sodium will become a ion. They are like to remove electron. They will become what? They will become a ion. So when you say sodium, now sodium, what is the atomic number? The atomic number of sodium is 11. What can you say about the electronic configuration of sodium? 2 comma 8 comma 1. So which means they are removing one electrons to become what? They are removing one electrons to become stable as 2 comma 8, become 2 comma 8. So which means now what is happening? Now sodium, initially sodium is like that, they are becoming what? Na plus. So initially sodium was, it was an atom. Now it has become an ion. So sodium was an atom. Now it has become an ion. What ion? It has become a positive ion. So in the first ionization, what you need to understand is, say for example, especially first ionization is about removal of electrons. First ionization means what? It is a character of the periodic table. We can say it is a part of the periodic table. According to that only all the elements are being arranged. So first ionization means that means you're removing electrons. So removing electrons to become a positive ion, we call that as first ionization. So first ionization means what? If an element, if it is removing electron to become the positive ion, we call it as what? First ionization. So in your exam, sometimes they can ask you the definition of first ionization. Sometimes, especially I have seen in MCQ, like not MCQs, they have yeah, MCQs also it's possible. Also I have seen in your term papers. In your term papers, they have asked the definition of first ionization. So listen to me, the definition of first ionization. If you take the first ionization, they are saying if you take any element, if that element is removing electron to become a positive ion, one unipositive ion, we call it as what? First ionization. So when is this first ionization is taken place? Now say if the sodium is in the state of gas. Let's say if the sodium is in the state of gas. Now if you supply heat, now if the sodium has to be evaporated, if the sodium has to be removed, what are you doing? You are supplying a minimum energy. So remember, if you are supplying a minimum energy, if that particular element is turning into a positive gaseous ion, we call that as what? First ionization. So if you take the first ionization, when you go across the periodic table, when you go from this side to this side in the periodic table, first ionization will be increasing. Now, some people, they might be confused. Okay, first ionization increasing means they will think, that means the amount of elements who can remove electron. You might be thinking, right? Increasing, that means increasing first ionization. When you go across the periodic table, you will be increasing the first ionization. The elements will have the highest first ionization. So remember, highest first ionization means how much difficult is to the element to remove the electron. Only we say increasing first ionization. Listen to me. Listen to me. Now first ionization means what? Removing electron, right? Just understand, removing electron to become a positive ion. That's it. But you have some elements you have to remember when you go across the periodic table. When you go from here to here in the periodic table, first ionization will be increasing. So first ionization is increasing because of what? Because the word first ionization increasing means how difficult for that particular element to remove the electron only. They are saying has increasing first ionization. So when you go downwards the periodic table, the first ionization is what? The first ionization is low. That means how easy for the element to remove the electron. So when you go down to the periodic table, the elements down, they are feeling easy to remove the electron. When you go across the periodic table, the elements are feeling hard to remove the electron. So that is what we say. So the group, what that means, the group 8 element helium, the group 8 element helium is having the highest first ionization. So what are you going to learn? So the who is having the first ionization, who is having the highest first ionization, that is going to be the helium. Who is going to have the least first ionization? That's going to be the element potassium. So now you have to understand that clearly. Got the idea? Understood? Clear with that? Right. Okay. So, what is the next thing that you can say? What is the next thing that you can say? You have to learn to draw the first ionization graph. So, why am I telling you to learn to draw? Because every year you can get a first ionization graph. Sometimes they will give you a unnamed first ionization graph. So, you should be able, they won't give you the complete graph. They will give it from the center, they will give it from the latter part of that, they can give you the front part of that. So you have to be ready with the shapes. So let me teach you how to draw the first ionization graph. So you have the y-axis and the x-axis, right? So if you take the first ionization, you measure it by per joule, that means per mole joule. So that means per joule, like not like that. You say per kilojoule per mole. So per kilojoule per mole is the unit you measure the first ionization. So you will be measuring that by this unit. So if you're drawing the first ionization graph, so first in the y-axis you have the first ionization. So first ionization, you can write it over here, first ionization. You have to write the unit that you are measuring it. And then here you should have the atomic number. So we can write the atoms. So especially they are taking the atomic number, so you don't want to worry about it. So listen to me how to draw it. The first rule is start from the center. Start from the center. So if you start from the center, go like a mountain. Go down. Don't go too deep. Don't go too deep. So once you go down like this, go like a step. 1, 2, 3. So second mountain has to be the lowest mountain than the first mountain. Then go a little deeper. Go a little deeper than this. Go a little deeper than this. So you can come like a, put it like a A shape. Once you put like a A shape, then you put like a step. You take like this and stop here and you leave it. So this is how you draw the first ionization graph. So first ionization graph, sometimes in your exam, they can give you this part. They can give you this part. So it depends. I have just drawn you the complete first ionization graph. Let me teach you how the placing comes. Okay, how the placing comes. So the placings of the elements in this graph is, listen to me, starting you have a point, right? That's going to be hydrogen. This point, helium. This point is going to be what? What is this point? You have the lithium. Then this point, beryllium. This point, boron. Then remember from the boron, only the center people, that means the center of the staircase will get marked. So you will have the carbon. This point you have the nitrogen. This point you have the oxygen. Yes, you will have the oxygen. And then you will have the fluorine. Then this point you will have the neon. So here also same. So here what? You will have the sodium. This point you will have the magnesium. So magnesium, sodium, in between nothing is going to happen. They will be like in the shape of A if you look into your textbook. So that's the best way to identify whether it's the last part of your diagram or the first part of your diagram. So if you have like a A like a shape in the second mountain. Sorry, it's first mountain, second mountain, third mountain. If you take your third mountain, if you see like a like a shape like this, like a triangle shape like that, then remember it's going to be sodium, magnesium. Then you have the aluminium. From the center of the aluminium, you're marking silicon, phosphorus, sulfur, chlorine, argon. Then you have the potassium, and then you have the calcium. So these are the markings of your first ionization graph. So this is going to be the markings of what? These are the markings of your first ionization graph. Did you understand how to draw the first ionization graph? Yes. Did you get an idea how to draw the first ionization graph? Right, great. So now what is happening? By using the first ionization graph, you should be able to answer the questions that is already mentioned. So first you need to identify. If you identify the elements that is in the graphs, you can simply answer all the questions easily. So the first thing is identifying is very, very important. Right. Now you are going to study about electronegativity. What you are going to study about? You are going to study about what? Electronegativity. So if you take the electronegativity, okay, if you take the electronegativity means, look here, electronegativity means electrons. That means electronegativity means, now first ionization, you are removing electrons. Electronegativity means you are accepting electron when you are bonding. We call that as what? Electronegativity. So if you take the electronegativity, especially the highest electronegativity, you can find it where? When you go across the periodic table, the highest electronegativity, you can find it in the group number 7. That's going to be the fluorine. Because group 8 will not be involved, because group 8 is the noble gas. They don't like to accept electron. They don't like to remove electron. So because of that, they are what? They are coming under the noble gas. So you can't take the group 8. So group 7, fluorine, has the highest electronegativity because the mostly non-metals likes to accept electron. But these people, the metals, do they like to accept electron? No, they always remove electron. Did you understand? Clear with that? Right. So when you go downwards the periodic table, the electronegativity will be decreasing. That's going to be with the potassium. So here in the first ionization, you are saying across the periodic table, that means the first ionization is increasing because of what? Because of what it is increasing? You said it was because how difficult to remove the electron, right? But here, how easily, how fast, or how potentially that the elements like to accept electron only. You are saying when you're going across the periodic table, the people on the what? On the right hand side, they love to accept electron, which means that's the reason electronegativity is high. The down the periodic table, the electronegativity will be low. That's going to be what? That's going to be the potassium. So right now we have to come to the isotopes. So if you have no idea what is isotopes, just listen to me. Isotopes means an atom with same atomic number. That means if you have an atom, if that atom has the same atomic number with a different mass number, we call that as what? Isotope. So if you take the isotopes means what? If you have the atomic number with the, that means if you have the atom with the same atomic number with a different mass number, we call it as what? Isotope. So especially if I take the carbon, so you will have the mass number here 12. The other carbon, you will have the mass number here 13. Here you will have the 14, but the atomic number will be same. So this is, we call it as what? We call it as isotope. So why do you create isotope? Why is the mass number is different? The reason is, I already said you, how do you calculate the mass number? Proton plus neutron, right? If you take the proton, always proton will never change. The proton will never change. But who is making the who is making the changes in the mass number? That's going to be neutron. So you have to understand, Neutron is the reason that you are creating the isotope. So when there is a change in the neutron, there will be a change in the mass number. If the mass number changes, we say that as isotopes. So the isotope that is mentioned in your book with the name is the hydrogen isotopes. Like if you have the mass number with 1, 2, 3 with the same atomic number, we call these as what? Protium. We call these as protium. We call these as deuterium, and this one we call it as tritium. So the isotope with 3 mass number, we call it as tritium. The isotope with the mass number 2 is deuterium. The isotope with the mass number 1 is, we call it as what? Protium. So just remember the isotopes, the names, and this is how the isotope will be appearing. The reason behind the isotopes is very, very important. Are you clear with that? Are you clear with that? Right. Okay. So now what is the main thing that you have to remember is, I told you about the metals and non-metals, right? Then if you take the left hand side, if you take the left hand side of the metal, I mean, if you take the left hand side of the elements, you find metals. If you take the right hand side of the, what do you say? If you take the right hand side of the elements, you find the non-metals. So metals and non-metals are divided by who? By the metalloids. So what do you mean by metalloids? Metalloids means who can act as a metal as well as non-metals such as silicon and boron. So silicon and boron are being the metalloids who are dividing the difference between the metals and non-metals. So let me teach you some characteristics of the metals and non-metals so that you will understand. So when you take the metals and the non-metals, if I take the metallic elements and if you take the non-metallic elements, you have to learn some physical properties. Okay, physical properties. The first physical property of a metal is they are always malleable. Malleable means you can, what do you say? You can hit and you make them into sheets. We say malleable. Then the, what is that? What is the next thing we can say? They are malleable. The next thing is we can say they are ductile. Ductile means you can draw them into wires. That is the physical characteristic of a metal. Then we can say they can be luster. Luster means what? They can be shiny and they can be sonorous. Sonorous means they can create a sound, ting ting sound. So that is, we call it as what? Sonorous. And then they are good conductors of heat and electricity. So that is the best example and that is the best characteristics, I would say, when it comes to what? When it comes to the metals. Non-metals will be opposite. Non-luster, non-ductile, non-malleable, non-sonorous. They're easily breakable. Like we say brittleness. We say what? Brittleness. So brittleness means what? They are easily breakable. So that is one of the feature that we can say under the non-metals. They are not a good conductors of heat and electricity. That also can be taken, right? So the next thing is, when we say about the metals, like let's say the chemical properties of the metals, always remember metals, they always likes to remove electron. They always likes to what? Remove electron. Non-metals, they always likes to accept electron. So since they are removing electron, all the valencies that you are getting under the metals is what? Positive ions. We call them as cation. Then non-metals, they always accept negative things, the electrons. Then what will happen? They will become anion. So whatever, even the water or the oxygen combines with a metal, they will become bases. If the metal, non-metals, if the non-metal combines with the water or oxygen, they will become what? They will become acid. So other than that, now if you take the lesson, under this lesson, if you take the important parts, like if you take the sodium, the characteristics of sodium, the physical and chemical, so special things I will say you. Sodium can be cut with a knife. It's a soft metal. It can be cut with a knife. If you burn the sodium, you will get a yellow flame. You will get a yellow flame. Then sodium used in denim dyes to make the lamps, street lamps. And if you take the sodium, They are always what? They cannot be kept outside because they are highly reactive, stored in a paraffin oil or kerosene oil. So they are stored. That is the specialty of the sodium. Then if you come to the magnesium, they are tarnished. Like what do you say? It's like a strip. Magnesium is a strip, especially we use in the firecrackers. Like we say, yeah, we use in the firecrackers. And especially the magnesium is what? They have higher density than the sodium. And also we can say magnesium, if you burn, it will be giving the white bright flame. Magnesium is used in what? To create medicines for the gastritis. So these can be the uses we can take under the magnesium. Then come to the nitrogen. So nitrogen is one of the inert gas, especially when you buy a chips packet. Inside the chips packet, you have some gases that you call it as the inert gas. That's the nitrogen gas. Especially we use it as a blanketing gas. We use it to, what do you say, the nitrogen gas most of the time to fill tires, vehicle tires, we use the nitrogen gas. And also nitrogen gas is helpful for the plant, especially when it comes to the nitrogen fixation. And when we say about the physical property, chemical property, they are colorless, odorless. Nitrogen, they have a very strong bond. They will be only break the bond during the thundering, during an electric spark. At that time they will be breaking the bond. Then come to the carbon. So carbon can be found as two forms. We call it as amorphous form, and other one we call it as crystalline. The word that we give the two structures, we call it as allotrophs. What is the name that we give for the carbon? We give it as allotroph. Allotroph means what? If they have two different structures. So if they are showcasing two different structures, that we call it as what? Allotrophs. So when you take the allotrophs of the carbon, one side is a crystal form, other side is a, what do you say? It can be found as the amorphous, like a very solid, like what do you say? Not a solid. It can be found as a powdered way. So crystalline form, they have 3D structure. Amorphous form does not have 3D structure, especially diamond, graphite can be found as what? They can be found as a crystalline in the carbon. So especially carbon, diamond has the high density. They used to cut gems used in the pivots of the equipment. And if you take the graphite, we used to make what? We used to make the pencils using graphite. Graphite can conduct electricity. The only non-metal that can conduct electricity is what? The graphite. Then if you take the other side of the carbon, like charcoal, lamp soot, coal, these will be helping us, like it's black color, it helps us in absorbing gases. And also we can say that is used for the cleaning purpose. So you can write about the carbon. And carbon is also not that reactive person, it's not a reactive element. Come to the sulfur. Sulfur also you can find it in two forms. When you burn the sulfur, you will have the blue flame. In the sulfur you will have the blue flame to make sulfuric acid, to make the vulcanized rubber, to make the paint, you take sulfur. So sulfur, you can find it in the crystal form, you can find it in the powder form. Crystal form, yellow color, brittle, solid. If it is the powder form, you find it is as a white color powder. So then come to the boron, we make skin creams using the boron. And also we can find it as a native element in the nature. You can find the boron just. So boron is like, what do you say, it helps us making in electrical equipments and everything. And also we can say like silicon, it is also closer to the silicon. Silicon also help us to make the electronic items, especially like solar panels, solar cells are made out of what? Silicon. So silicon, another name we call it as sand. So silicon also have two structures, especially quartz. They can have kind of gems, quartz, marble. These are the different types of what? Silicon. So this is about your Unit 3 grade 10. Are you clear with that? The mostly tested one I have been explaining you, especially in MCQ as well as in your what? Especially in MCQ as well as in your structured essay and essay type question. Did you understand? Clear with that? Any doubts? Any doubts? Got the idea? Right, okay. I will be explaining you about the Unit 7. electronegativity graph is important. No, it's not important. I mean the table, right? No, that's not important, and the chart is not important. Only first ionization is important, right? Okay. So let's go to the unit 7. Under the unit 7, let me teach you only the things that is only important. So let's say when it comes to Avogadro's constant. So special part that you have to learn is what? Avogadro's constant. So when it comes to Avogadro's constant, the scientist Avogadro is the person to introduce about what? Avogadro's constant. Now in chemistry, they have given you, now say for example, they have given you the masses of the elements. Now if you take the elements, they have given the masses of the elements. Let's say if I take sodium, the mass of the sodium is 23. If you take the hydrogen, the mass of the hydrogen is 1. If you take the oxygen, the mass of the oxygen is 16. That means the scientist has been identified that means they have found a mass of the each element, so they have given you the masses of the element. So Avogadro's constant means, now I'm asking you a question, can you count atoms? Can you count atoms? You can't count atoms, right? So if you can't count atoms, and in exam if they ask you to give the values of the atoms, can you give it? Can't. So since because of that, we exactly don't know how much of atoms will be there in sodium, hydrogen, oxygen. So the scientist Avogadro, he created a common, what do you say, common value for all the atoms. So he said that if you take the mass of sodium 23, or if you take the mass of the hydrogen, if you take the mass of the oxygen, he said that the amount of atoms that will be present in each of these element will be what? 6.022 into 10 to the power 23 atoms. So this much of atom will be there. So he said that if you have, now say this is the fixed value for the mass of the sodium, right? This is the fixed value for the hydrogen, right? This is the fixed value for the oxygen. Right now if I take the sulfur, the fixed value for the sulfur is 32. So the values are not important. That means the values, the masses are not important. They are, he's saying that if you take a specific mass of an element, if you take a specific real mass of the element, that mass will contain this much of atom. He said that that mass will contain this much of atom. So what do you need to understand? Now say for example, now this is the mass of the sodium, right? Now in exam they have given you the mass of the sodium is 23. Okay, now just understand. Mass of the sodium is 23 means how much of atoms will you have in the sodium according to the Avogadro's constant 6.022 into 10 to the power 23. This much of atoms will be there in the sodium. And then in the next statement they are saying that the boy is having half of the sodium. That means they are saying half of the mass of the sodium, which means 11.5. They are saying that this much amount of sodium only he has. He should have this much amount, but he has only this much amount. That means they are asking how much of atoms will the 11.5 grams of sodium will you have. Now you know that 23 is this much of atom. Half of the 23 is 11.5. That means if you are dividing this 6.022 into 10 to the power 23, then the half of that only will be equals to the 11.5 grams, this much of atom, which means 3.011 into 10 to the power 23 atom. This much of atom will be there in 11.5 grams of sodium. Now, did you understand the concept? Did you understand the concept? So Avogadro is saying that whatever the original masses that you take, whatever the original masses that you take for the element, that element will have only this much of what? Atoms. So by comparing that only, you are finding the answers. Okay, so let me give you a sample question. So when I give you a sample question, you will understand exam something like this. Okay, so let me give you a question so that you will understand, so you will get an idea. Let's say for example, let's say for example, they have given you exam, the hydrogen, no, the mass of the water. Okay, let's say for example, we'll take a question, a general question. Okay, I will take a general question to make you understand. Say for example, let's say for example, they are saying that a boy is having 36 grams of water. He's having 36 grams of water. Now, if I take the water, water is an atom or is it a molecule? Is it an atom or is it a molecule? I mean, like, is it a compound or an element? It's a molecule, right? Water is a molecule. Also, it is also considered as a compound. So that means first question they will ask you is find the relative molecular mass. Find the relative molecular mass. And next thing they will ask you to do is find the number of atoms in the molecule. So you have to find the number of atoms in the molecule. And oh no. They can ask you find the number of molecules. They can ask you find the number of molecules in this water. You have to find the number of molecules. Now I'll teach you that point. Listen. Third one, they can ask you find the number of atoms. So they can ask you to find what? Number of atoms. So first of all, listen to me. So this is how the question comes, especially in MCQs. I'm just putting all of them together to make sure that you understand. Listen to me. Now they have given you a certain value, right? They have given you a certain value of the mass of water. And also in the bracket, they will give you the relative atomic mass. They will say hydrogen value is 1, oxygen value is 2. Now, how to find the relative molecular mass? You already know. If you take the relative molecular mass, you can take the water. Can you tell me the value of water? Value of water is 1 multiplied by the value 2 plus 16. Then totally the relative molecular mass is 18 gram. That means if I take the 18 gram, let's say if I take the value 18 gram, in the 18 gram, how much of molecules will you have in this 18 gram? How much of molecules will you have according to the Avogadro's constant? You will have 6.022 into 10 to the power 23. This much of molecules, this much of atoms you will be having according to the 18 gram. Now, do you have 18 gram or do you have 36 gram? You have 36 gram. So 36 gram is twice the time. That means it's going to be the twice the time of the initial amount. That means it's 2 times the initial amount is 36. So that means you have to find the relative. I mean, you have to find the number of molecules in 36 gram. So that means we know in 80, if you have this much amount, when it comes to 36 gram, how much of molecules will you have? You have to multiply 2 into 2 into 6.0 into 2 into 10 to the power 23. So which means 2 into 6 is going to be 12. 12. Anything multiplied by 0 is 0. You will get this as 4 into 10 to the power 23. So this much of molecules you will have. What's the next question? Number of atoms. Remember, this is a molecule. Inside the molecule only, you will have the atoms. So can you tell me how many atoms do we have? How many atoms do we have? How many atoms do we have? Now see, look here, look at the values here. Hydrogen 2 times. You have hydrogen 2 times. And you have oxygen 1 time. So that means how many atoms do you have? You have 3 atoms. So that means the value that you got here has to be multiplied by 3 times. So if you're multiplying it by 3 times, that means this value is going to be the value for the number of atoms. So if they give you the value, let's say if they give you a question related to this one. Let's say, for example, if they have given a molecule, first they will ask you to give you the relative molecular mass by giving the relative atomic mass. What do you mean by relative atomic mass? They have given the masses of each element. By using that, you have to find the mass of the molecule. You have to find the mass of the water. So you found the mass of the water as 18. So if I take the 18, according to the Avogadro's constant, he says whatever the fixed value, whatever the real masses, those masses will have this much of molecules, this much of what, this much of atoms as this amount, because we can't calculate, we can't identify that. So since we can't see the molecules, or since we can't see the atoms, he just asked us to fix this value. So by this value only you are solving any of the questions. Did you understand? Did you understand how this is working? Did you understand how this is working? So especially it will come to your MCQ. Any doubts in that? So if you take, okay, so if you take, okay, listen, okay, I got so many questions. So if you take the values, okay, if you take the values, you have to simplify. You have to simplify in the sense, if you multiply and if you get the value, you will understand, right? I will give you a question, try to do that question, I will do it with you, so you will understand, so you will get an idea. So make sure your messages, it's just disappearing, I have to search one by one. It's really complicated. Earlier in Zoom it's not like that. All the messages will be in one place and it's easy for us to identify. But I'll give you a question. If you can do that properly, the same thing will be applied in where? In your MCQs also, right? So look here. Let's say, for example, let's say they have given you, you have, let's say, for example, they have given you, you have 49 grams of sulfuric acid. So in the statement, they have said that you have 49 grams of sulfuric acid. And they have given in your paper as the relative atomic mass, as given as hydrogen is 1, oxygen is 16, then the sulfur is 32. So these are the values they have given. The first question they can ask you, find the relative molecular mass. So here, sometimes they don't ask you to find the relative molecular mass, but they can ask you to find the amount, the exact amount of the molecules, the exact amount of the atoms they can ask, but just give a try, okay? The next one is they can ask you find the number of molecules. So you have to find the number of molecules and also you have to find the number of atoms. So if you can do both of them properly, so these three questions properly, then you don't have any doubts in the lesson 7, because the lesson 7 is the very shortest lesson. The main point is, if you know to find the answers related to the Avogadro's constant, then that's it. So just give a try. You can try this out. Yes. Just give a try, okay? You can just try, okay? So they have given this much only you have. But what is the relative molecular mass? You have to compare the relative molecular mass with the Avogadro's constant. So if you compare it, you can see the relative molecular mass, you can compare it with this value. And then you can find the number of molecules, number of atoms, you can find it down, right? Give a try. If there's any important question, I will be answering. You don't have any units, okay, Apsa? You don't have any units for that. For the number of molecules, number of atoms, we don't have any units. For the relative molecular mass also, they don't have any units, okay? No units. But Ruqayya, for the O level, you will not get. You will get only first ionization. For the electronegativity, they like it's very rare. Okay, it's very rare. Yeah, Zainab, if you study all the three recaps, you can get an A. How the elements placed on the periodic table. So the elements placed on the periodic table based on first ionization, based on the electronegativity, and with their characteristics, the reactivities. So the mainly we can say based on the ionization, based on the electronegativity. So we can say the two characteristics of periodic table or two factors that is depending on the periodic table is those two. That's what we are learning about them. If you have done, we can discuss. Look here. Look here. So here they have asked you to find the relative molecular mass. How do we find? Write it as H2SO4. So 2 times the hydrogen. So hydrogen 1 multiplied by 2 plus sulfur 32 plus 16 into 4. So if you are getting all these values together, you will get the answer as what? You will get it as 96. Okay, so 96 gram will be the relative molecular mass. So if you take your relative molecular mass, okay, if you take the relative molecular mass, you can take it now half of the 96, okay? Half of the 96 is going to be what? 49. So according to the 96, we can take it as what? So it's going to be, wait, I will just double check. It's going to be 98. Okay, so if you take the 98, so what is going to happen if you take the 98? The half of the 98 is going to be what? 49. It's going to be 49. So if you take the 49, which is going to be the half of the 98, so half of the 98 is going to be the 49. If you take the 98, what is the relative molecular mass? You found 98. What is the number of molecules? The number of molecules is going to be 6.022 into 10 to the power 23. This much of molecules will be there. But do you have 98 grams? No, you have half. So half of the Avogadro's constant will be the value for the 48 grams, 49 grams of the, what do you say, the 49 grams of the sulfuric acid. You will half of this, which means 3.022 into 10 to the power 23. So that's going to be the number of molecules for this value. Then if you're finding the number of atoms, how many atoms do we have? How many atoms do we have? So you have two there, two hydrogen, one, then three, plus four, totally you have seven. So you multiply the seven with this value to get what? To get it. So if you're multiplying 7 multiplied by 3.022 into 10 to the power 23, then this will be the value of what? This will be the value of the number of atoms. So 7 into 3, 21. Then you multiply them and you get the values. Clear? Got it? So that is about what? That is about the Avogadro's constant. Most of the time, Avogadro's constant will be what? It will be about the calculations, but the calculations you have to, what do you say? You have to find the relative molecular mass, number of atoms. According to that, if you can answer, that's it. Now you have to come to the next part of your lesson, that's about the moles. You have to find the moles. So to find the moles, you have to just remember the equation. You have to just remember the equation to find the moles. So to find the moles, you have to use the equation number of moles equals to like we say mass over molar mass. So if you take the number of moles, we can take it as what? Mass over molar mass. So number of mole is equals to what? Mass over molar mass. By using this, you can find what? Number of moles. So remember, relative atomic mass, relative molecular mass, Avogadro's constant. Then when you take the number of moles, these people, now number of moles has a unit M. They have the unit m mole. They have the unit mole. Then if you take the mass, you measure it by gram. If you take the molar mass, remember molar mass will have a unit gram per mole. Gram per mole. Remember, relative molecular mass and molar mass will be equal. That means the same method you find the answer. But the difference between the molar mass and relative molecular mass is what? That is going to be gram per mole. Other one is going to be without the unit. So you will not have the unit for what? Relative molecular mass. Clear with that? For the relative molecular mass, you don't have any units. But for the molar mass, you have the units. For the mass, you have the unit. For the mole, number of mole, you have the units. Relative atomic mass unit, those people does not have what? They don't have any units. Clear with that? Got the idea? So in this lesson, there's nothing to remember. Only the thing is the Avogadro's constant. You have to just understand the Avogadro's constant. If you can find the Avogadro's constant clearly, and if you can find the number of moles clearly, then remember that lesson is easy to understand. Let's say if they have given you, okay, if they have asked you to find the number of moles, say for example, let's say for example, they said that you are going to have the mass. Let's say they have saying that in the water you have this much amount of, let's imagine they are saying this much amount of water you have in a bucket. Let's say they are saying 180 grams of water is in a bucket. And also they have given in the relative atomic mass has been given, hydrogen is 1, oxygen is 16. And also the next part they have given, find the molecular mass. You have to find the molecular mass. And the next one is find the number of moles. You can find the number of moles. It's very easy. I'm just showing you how to find the number of moles. So find the relative molecular mass. How would you do it? Already you found as 18. So what can you do to find the number of moles? Number of mole equals to mass over molar mass. I told you molar mass also equals to the relative molecular mass. Both of them will have the same way, but molar mass will have the unit. So what will happen? Mass is 180. 18, you cancel out, you will get the value as what? You will get the value as 10 moles. So that means in in water, you will have 10 moles. In 180 grams of water, you will have how many moles? You will have 10 moles. So this is going to be the very simple way. And you remember, unit 7, like very like 1 mark, 2 mark questions only, you will get it from the unit 7. So always unit 7 will be combined with what? It will be combined with your lesson grade 11, unit 3. It can be connected with your unit 12. So it depends on the situation, because unit 7 does not come alone. They always combine with any other lesson. So that's how you get the questions related to the unit 7, especially in MCQs. I have seen at least 2 questions you get out of this lesson, especially in MCQs if you wanted to find them. So that is how you will be getting it, right? Clear with that? Got the idea? Right. Which one is this, Rukaya? 1.98 grams. Like, I'm not sure. I mean, like, what is this question is about? We did about the Avogadro's constant. Yeah, okay, yeah, that's correct. Your answers are correct. First, I was confused because you mentioned like this. You have mentioned it as question number one, right? So just now I realized that's question number one. First, I was thinking why there was decimal like this. You have sent like this. So when I see it, I was confused first. Yeah, that's all correct. That's all correct. Right. Okay. So unit 10, unit 16, and also unit 17 along with your grade 11 chemistry lesson. I will be discussing it in our part 2 day. I'm extremely exhausted today because I had my exams. So once I have completed my exams, I have been doing classes till now and I'm so exhausted. So yeah, that's the main reason I was struggling to speak and I was having some tongue twists. That's the main reason, because when I'm too tired I can't continue because I won't be that energetic. But anyways, thank you so much for joining, and we'll have a better session by next session by December. I will keep posting you the date soon, inshallah. And yeah, have a good day, take care, good night. I'll update you everything soon, and see you in the next class. Thank you so much for your patience, means a lot.